Dear viewers, welcome to another video in the series of descriptive statistics using Microsoft Excel in data analytics. In our previous videos, I was explaining about how we can use descriptive statistics option available in data analytics plugin, as well as how we can use descriptive statistics option available in Minitab to create a summary of descriptive statistics. However, in this video, I am going to explain how the same descriptive statistics can be calculated using the Excel functions, not using the add-in, not using the Minitab option, but instead how we can use individual Excel functions and still generate a same descriptive statistics. Let's get into the video. As I was explaining in the introduction, in my previous video, I have given how a descriptive statistics can be performed as a summary and displayed in the Excel file for a given set of data. So I will share the video link in the description if you want to understand how the summary can be created using the data analytics add-in of Microsoft Excel, or how a much elaborative descriptive statistics can be performed using Minitab descriptive statistics option. So I have made a video on that. I will share the link in the description. However, in today's video, I have decided to explain what is the Excel function by which the same descriptive statistics can be calculated. So for that, what I have done is I have taken all the descriptive statistics that get calculated during or using Microsoft Excel data analytics plugin as well as Minitab. So I have consolidated the entire list of descriptive statistics that get displayed when you are using Microsoft Excel or you are using Minitab. So I have combined both. So for that combined list of descriptive statistics, what are all the Excel functions that we need to use? That is what I'm going to explain in this video. So to start with average, and many of us know what is the average function. As you see here, I have given the function here. So what we need to do, we need to use the average function. So let me explain you how does it work. So here I have calculated the average function, and if you see the formula, you need to type average, open brackets, and you need to select the entire data set. So if you select the entire data set and close bracket, you get the average value, exactly the same value that you get when you are using the descriptive statistics plugin using the data analytics. Similarly, if you want to calculate standard error, we have already seen standard error is basically a derived value, and if you see here, the formula for standard error is standard deviation divided by square root of n. And if you see, it is not a single function, it is combination of two things. So what I have done, I have already calculated standard deviation separately, and if you see here, the formula that I have used is standard deviation dot s. So standard deviation dot s is nothing but standard deviation of a sample. So if I apply standard deviation dot s, I will be able to know the standard deviation value. And similarly, if I use the count function, if I use the count function, you see here, if I use the count function, I will be able to know the number of data points. I have used the count function here for the data. I will be able to know the number of data points. So when I have the count function and when I have the standard deviation, when these two values are available, then I will be able to calculate the standard error. So standard error, the function is, if you want to use a single function directly, you can say standard deviation of the data divided by square root of count of data. This is the function. So friends, if you think this Excel copy being sent to you will be helpful, I will share the email address. So kindly write to us. We are more than happy to share this Excel file with all the individual functions so that it becomes easy for you to do the same functions and display descriptive statistics. Now we will come to median. Again, the formula for median, very simple. So you need to type median and select the entire data set. So you will be able to get the median, exactly the same value. And when we are typing mode, I would just like to explain you one thing, friends. Mode basically can be understood using a formula called mode. However, there is one more formula, and that is called mode.multi. So if you see here, the traditional formula is mode. However, there is one more formula, mode.mult, and then you can open bracket and close bracket. And when this function can be used, this function can be used when you feel you can have multiple mode in your data, more than one data point repeating equal number of times. Then you can have multi-mode as an option. Just to make you understand, Let me show you an example. So here, for our understanding, I copy this data, Taylor1 data. I paste it here in a separate screen, right? 6.24 is getting repeated 2 times. I will copy and paste it one more time. And if you type is equal to mode, open brackets, and select this and close brackets, you will get 6.24 as the mode. However, if I copy paste 6.67 also 2 more times, right? Now if I type is equal to mode dot multi, right? That means if at all there is more than one mode, display all. That is a meaning. And if I type mode dot multi, you will get 6.24 as well as 6.67. So this is the formula for mode. You can either use mode, or if you think there could be multiple modes, then you can type mode dot multi, right? The next thing that we can understand in descriptive statistics is variance. So what is variance? We have clearly explained in a separate video how variance get calculated, what is the formula. But if you simply want to use a Excel function, you have var.s. var.s stands for variance of sample. If you want to do the same thing for variance of population, you can say var.p. So you type var.s and select the entire data point, you will get variance of sample. Then kurtosis. Again, we have clearly posted a separate video on what is the concept of kurtosis. Kurtosis is one of the metrics or one of the descriptive statistics which gives you how much data is falling on the tail of your normal distribution curve. So if more data falling on the tail, then the normality of your data can get disturbed, right? Or if more data falls more closer to the center line, then your data can be normal. So there is 68.3% of data supposed to fall closer to your central tendency, average or mean. So measuring that is what we call it as kurtosis. There's a separate video that we have posted on kurtosis. I would request you to kindly listen to that video to understand what is kurtosis. But to calculate kurtosis, you can simply use a function called KURT. Then you can have your open brackets and select your entire data point. You will be able to get kurtosis. And similarly, skewness. Skewness is again a descriptive statistics metric which tells you whether your data is symmetric. That means it has equal opportunity for variation on both sides, and both sides of the tail are equidistant away from your central tendency. So to know the skewness, you can type SKEW open brackets and you select the data, you will get the skewness. Range, we all know the formula for range is value of maximum minus value of minimum. So I am applying two functions here. Max, I select the data, minus min, I select the data, I get range. And similarly, the same max formula or the max function in Excel can be used to understand the maximum value. The min function can be used to understand the minimum value. And one more descriptive statistics that is available is sum of all data points. So we can simply use sum and we can select all the data points and we'll get sum of all data points. Count, I have already told what it is, what count is. It will count the number of non-blank cells and it will give you the value. Then we have something called confidence level. And if you see in descriptive statistics of Excel, the confidence level is calculated based on student T distribution. So how the student T distribution confidence level can be calculated? Confidence dot T. So when you use a function confidence dot T, then you say what is the level of significance that you want to have. So in this case, the confidence level has to be 95%. So for confidence level to have 95%, our alpha level should be 0.05. So I enter the first argument 0.05. Then I enter the standard deviation of my process. So the standard deviation of my process is already calculated here. And third argument should be the number of data points. So the number of data points also selected. So when I enter it, I will be able to get the confidence level for the average, how it get calculated, right? So this is the confidence level with students tree distribution. And similarly, the confidence interval is getting calculated here for normal distribution. And if you see this, this is the confidence interval for normal distribution. And the confidence interval for normal distribution is with, again, confidence dot norm, and get alpha value for 95% confidence interval. Your alpha value will be 0.05 and you get your standard deviation and number of data points. And this is how you get your 95% confidence interval value. Then the next thing that we are going to calculate is called coefficient of variation. Coefficient of variation again is a derived value combination of two functions. I calculate the standard deviation of my process, then I divide it with average of my process, which is nothing but mean, and multiply it with 100. So what is the standard deviation in terms of a percentage of the average? That is what we understand using coefficient of variation. So coefficient of variation generally do not come in your Excel descriptive statistics summary. So the coefficient of variation will come in your Minitab descriptive statistics summary. So from here on, what we are going to see are available only in Minitab descriptive statistics summary. So then you can understand the Q1 and Q3 values. So what is Q1, what is Q3? Again, in our Minitab box plot videos, I have clearly explained that. So I will share the link. However, in this case, you can use percentile.exe. So percentile.exe, the syntax of the function goes like this. You need to select the entire set of data for which you are calculating, and then you can put 0.25 for you to get the first quartile value, and you can put 0.75 for the same formula to get the third quartile value. And finally, if you find the difference between these two, that will be your interquartile range, or in other words, IQR. So IQR will represent the center 50% of your data. Then we have trimmed mean. Generally, the concept of trimmed mean is nothing but how much you would like to trim your outlier data, and then you calculate your mean. So in this example, I have applied the entire data. Then I say trim 15% of data. So trim 15% of data means your top 15% of data and bottom 15% of data will get trimmed, and you will get the value. You can apply same trimmed mean for 10%, 5% depending upon how much you want to trim. But trimmed mean is nothing but if you feel your data have outlier and you want to curtail the outliers and you need to calculate mean only with the remaining data, then you can use a concept called trimmed mean. So the function is trim mean, and the syntax is you can use the entire data and how much percentage you want to trim. Then you have something called sum of squares. So what is sum of squares? Again, we have posted a separate video on sum of squares. So in this particular example, when I put sum of squares for the absolute value, so there are something called sum of square for the absolute values and sum of square for the deviation. But here what we are doing is we are applying sum of square for the absolute value. That means each of this individual value will be squared, and then it will be added and it will be represented here. So the formula is sum of squares. Then we have to calculate something called mean successive deviation. So in descriptive statistics, mean successive deviation alone is not calculated using a function. It is calculated as a derivation. So let me explain how the derivation works. So now here I have hidden few data points. So I'm going to highlight those data points now. I'm going to change the font color. Now if you see here, this is the squared deviation of two successive data points. So what we are calculating here, this is the squared deviation. So the difference between the first data point and second data point, so that could be in positive value or negative value. So in order to take the sign out of that, we are squaring it. So step number 1, calculate the deviation and then square it. So that is the first thing that we do. And the next thing that we do is we create a sum for the squared values, right? So we create a sum for the squared value. The numerator is sum and denominator is n minus 1. Why n minus 1? Because this is successive deviations. Even though you have 30 data points, you will have only 29 deviations. So this is the value 1.137. This is the mean successive squared deviation. And then finally what we do, Minitab gives half of your mean successive squared deviation. So what you see here, we have calculated mean successive squared deviation and then we have divided it by 2. So this is how the value get displayed in Minitab, and you will be able to get this value. And now we have something called in Minitab, you will be having n missing. So n missing is nothing but in your given set of data, is there any blank values in between? So for that in Excel, the function that we can use is when I say count A, it will collect or it will count the non-blank cells. And when I use count, it will collect only the numeric cells. So you can say count A minus count, it will give you only the numeric values. So there is no missing value here. And count non-missing, right? So when you say count non-missing, we are counting the number of data points. That is what we call it as count non-missing. And count total is nothing but together count missing and count not missing, totally how many data points we have. That is what we have in this last section of your descriptive statistics of Minitab. And the last two data point, percent and cumulative percent, not relevant for a single set of data. If you collect data in the form of subgroup, then these values are relevant. So at this point of time, these two values that you get in descriptive statistics of Minitab is not relevant. So friends, if I want to quickly summarize, if you use data analytics, and if you use this descriptive statistics and you select a data, you will be able to provide or produce this kind of a descriptive statistics. Similarly, in Minitab, when you click on stats, so let me go to Minitab for a moment. So in Minitab, when you click on stats, you go to basic stats and you go to display descriptive statistics, you will be able to get descriptive statistics. And if you get into this, all these things can be checked and you can get a descriptive statistics. For both these, I have posted separate videos as I explained before. Now what I have done is I have not used the display descriptive statistics option of Excel data analytics plugin or Minitab. Instead, I have individually used functions and I have calculated the same value. So knowing what function is being used or what kind of formula is being used when these descriptive statistics are getting calculated will also be useful for you in future, where you don't have access to Minitab or you are not able to add in the plugin. If you are using an older version of Excel and you don't have an option to add in these plugin, still if you know the function, it will be useful. That is the purpose of me posting this video. Thank you for your time. Thank you for watching this video. Please subscribe our channel for more videos on how we can do data analytics using Microsoft Excel. Thanks for your time.